Here's our topic. The infinity sign, remember, means it's everywhere in the curriculum for AP. Here's our objective. And the objective means if we know some things about a compound, like its formula and where it is, we want to know its oxidation state. And these oxidation states are going to be positive and negative integers. All right, here's the definition. This charge, the reason it's in quotation marks is it's not really a charge, in the sense that it's not an imbalance of electrons and protons. And the greatest attraction has to do with electronegativity. All right, I would copy this down, please. And just to remember, it's not a charge. It could be the same value. Now, oxidation state's got three main purposes, or three main ways that we're going to use it. Two are involved in the AP curriculum: redox reactions and half reactions. The other is naming compounds, and we'll get into that later in the video. Okay, here are the rules. I would pause the video now and copy them, even things that don't make sense, and I'll go through all of it within the context of the examples. So pause it and copy, please. All right, here's our first example. This is a polyatomic ion, nitrate. So first thing with polyatomic ions, you know that the overall charge is going to be equal to the charge of the ion. So this is -1. And oxygen, since it's not with fluorine or in a peroxide, it's going to be -2. So here we go. That's going to be -6, all right? And the overall is going to be -1. So what plus -6 gives you -1? 5. So that's nitrogen's oxidation state, +5. All right, now here's a peroxide. What's the oxidation state of oxygen? Now, it being a peroxide, you have to start with the hydrogen. And you know that hydrogen's +1, and you know that the overall charge is 0, okay? And the reason hydrogen's +1 is because hydrogen's with a non-metal, not a metal, all right? So there's 2 in each, so that gives you +2 each. In each case, it's going to be -2. But within the peroxide and not with water, there are 2. So in water, the oxidation is -2, but with peroxide, since there are 2 of them, that gets divided by 2, and my oxidation state is -1, as shown there. Okay, now, methane and carbon dioxide. Now, these are both neutral compounds, so the overall charge is 0. And I'm going to start with the oxygen in this one, because I know oxygen's always -2 here. There's 2 of them, so that gives me -4. That's going to add up to 0. So carbon's going to be +4. And in methane, I'm going to start with the hydrogen. Now, hydrogen's going to be +4 because it is with a non-metal. It's +1 because it's with a non-metal. I think I said that wrong. And that's going to add up. So in this case, carbon's going to change to a -4. Good observation, Angry Larry. How could it go from one to the other? All right. Well, Dr. Square is correct. It has to do with the electronegativity values. And he's saying it correctly here, too. Oxygen's more electronegative than carbon. It's going to be negative. Carbon's more electronegative than hydrogen. It's going to be the negative. All right. Now, let's go over oxygen difluoride. Well, oxygen's a -2. And, oh, thank you. Yes. Fluorine's always -1, so that can't be correct. And then I'm going to multiply that by 2. The overall charge of this compound is going to be 0. So oxygen, in this case, its oxidation state will be +2. All right. Now, this compound is a ionic compound. Its overall charge is 0. Now, it's not a peroxide, and because this BrO2 is a polyatomic ion, so I know that's why it's not a peroxide. So Na is going to be +1, oxygen is going to be +2, because group 1 metals are always +1, oxygen is always -2 in this scenario. All right. And here's what they're going to contribute to the overall that's going to add up to 0. So what integer is going to make this right? +3. All right, so bromine's charge or oxidation state, not charge, oxidation state in this case is +3. Now you'll notice that the subscript on the oxygen changed from 2 to 3. Therefore, nothing's going to change except that there's going to be more negative, and the oxidation state of the bromine is going to become +5. And that gets spelled out in the name, or sodium bromite and bromate. All right. Now, this is another example of how they're used, oxidation numbers. In this reaction, you've got two elements or two atoms in their elemental state with oxidation states of 0, rule 1, and they go from 0 to +1 and -1 respectively. And since sodium is going from +0 to +1, we call that oxidation because it's losing its electrons. And chlorine's going the opposite, and we call that reduction. This will be a topic for another video, okay? Thank you, and here are my sources, and thanks to little Frito and Angry Larry.